This is the first problem that was appeared in year 2018. You will find these sums in page number 40 of your scholar or scanner. The question is that given the following, expected return relating security X and security Y are given, and expected return relating to security X is 30% and that for security Y is 45%. Variance associated with security X is 16% and variance associated with security Y is 25%. In accordance with the Markovitch diversification principle, explain whether the risk-averse investors would have any diversification advantage in forming a portfolio of the above two securities in the following cases of covariance between their return. If diversification benefit is available, then determine the minimum variance portfolio combination and the risk and return profile of such combination. Here the covariance are given in question 1 is 16 and covariance in question 2 is minus 20. Now here the expected return of the two securities that are included in the portfolio are given. For security X it is 30%, for security Y it is 45%. Variance associated with security X is 16% and variance associated with security Y is 25%. That means risk, which is measured in terms of sigma for security X, will root over of variance, that means root over of 16 equal to 4%, and the risk associated with security Y is equal to sigma Y equal to root over 25%, that means 5%. So risk associated with security X is 4%, risk associated with security Y is 5%. Now we have to test whether, as per Markovitch diversification principle, the risk averse investors will gain any diversification benefit by constructing a portfolio with these two securities. If there is any diversification benefit, then we have to calculate the weight that is to be taken for security X and security Y, and for this weight, what will be the expected return of the portfolio and what will be the risk associated with the portfolio, that is also to be calculated here. Now for the first question, covariance is given as 60. Now we know that correlation coefficient between two securities, that is explained in terms of Rxy, is equal to cov xy divided by sigma x into sigma y. Now here cov xy is given as 60 and sigma x and sigma y, that means risk associated with security X is 4% and that is for security Y is equal to 5%. So putting this value in this formula, we will get the value of Rxy. Now when cov is equal to 60, Rxy, that means correlation coefficient between security X and Y, comes to 0.80. That means here the correlation coefficient varies from 0 to plus 1. Now since the correlation coefficient varies from 0 to 1, here we have to test the threshold condition. We know that when the correlation coefficient varies from, we know that when correlation coefficient varies from 0 to 1, then we have to test the threshold condition. What is the threshold condition? The threshold condition is that Rxy less than lower sigma by higher sigma. Here we have to make test of threshold condition where Rxy should be less than lower sigma by higher sigma. This is to be tested whether Rxy is less than lower sigma divided by higher sigma or not. If Rxy less than lower sigma by higher sigma, then threshold condition is satisfied and there will be diversification benefit. But if this threshold condition is not satisfied, then there will be no diversification benefit. Now here in the left hand side we have Rxy, that means 0.80. In the right hand side there will be lower sigma by higher sigma. Here lower sigma is 4%, that means sigma x, and higher sigma is sigma y equal to 5%. So in the right hand side we have sigma x by sigma y, which comes to 0.80. So here left hand side become equal to right hand side. So here the threshold condition is not satisfied. For satisfying the threshold condition, Rxy should be less than lower sigma by higher sigma. But here this condition is not satisfied. Since the threshold condition is not satisfied, here by constructing portfolio the investors will not gain any diversification benefit. So here the risk averse investors will invest their money in the lower risky security, that means in security X having a risk of 4% and associated return, that means expected return with 30%. So here the answer is that since threshold condition is not satisfied, here there will be no diversification benefit that can be attained by the investors by constructing portfolio with security X and security Y. That's why he will go for invest all his money in the lowest risky security, that means in security X having the expected return of 30% and risk of 4%. Now the second question was that what will happen if covariance between security X and Y is minus 20. Now since covariance is minus 20, here correlation coefficient, which is to be calculated by applying formula cov xy divided by sigma x by sigma x into sigma y, comes to minus 1. Since the correlation coefficient is minus 1, that means here security X and security Y are perfectly negatively correlated, and when these two securities are perfectly negatively correlated, then the investors will gain the maximum diversification benefit. But for getting the benefit of minimization of risk to 0, here the weight that is to be taken for security X will be sigma y divided by sigma x plus sigma y. Here the weight for security X will be sigma y divided by sigma x plus sigma y, and weight for security Y will be sigma x divided by sigma x plus sigma y. Now the measurement of weight where these two securities are perfectly negatively correlated and the formula associated with that point, that means where the correlation coefficient are minus 1, then what will be the optimum weight for security X and security Y? That is being discussed in our earlier class, and on that ground we can say that where the correlation coefficient between the two securities are minus 1, that means when the two securities are perfectly negatively correlated, then the weight that is to be taken for security X, that means Wx, is equal to sigma y divided by sigma x plus sigma y, and weight of security Y will be sigma x divided by sigma x plus sigma y. Here the value of sigma x and sigma y are given in the question. So here weight of security X is equal to sigma y divided by sigma x plus sigma y. Here sigma y equal to 5, sigma x equal to 4. So weight of security X comes to 5 by 9, weight of security Y comes to 4 by 9, and by taking this weight we have to calculate the expected return from the portfolio and the risk associated with the portfolio. Now we know that expected return of the portfolio is calculated by applying formula Wx into expected return of security X plus Wy into expected return of security Y. Here the weight of security X is 5 by 9 and expected return of security X is 30%. Here weight of security Y is 4 by 9 and expected return from security Y is 45%. So here the expected expected return of the portfolio comes to 36.67%. Now the portfolio risk is to be calculated in terms of sigma p, the formula of which is root over wx into sigma x whole square plus wy into sigma y whole square plus 2 into wx into sigma x into wy into sigma y into rxy. Here weight of security x is 5/9, sigma x is 4, weight of security y is 4/9, sigma y is 5, and rxy is -1. By putting all these values, we have sigma p equal to 0. So here the risk of the portfolio comes to 0, and we know that whenever the two securities by which the portfolio are to be constructed are perfectly negatively correlated, then if the weight of security, if the weight of these two securities are calculated in proper way, then in that case we can reduce the portfolio risk to 0. That means there will be no portfolio risk where the securities are perfectly negatively correlated, and we calculate the weight that is to be taken for security X and security Y, or for security A and security B, which is equal to sigma Y divided by sigma X plus sigma Y for security X, sigma X divided by sigma X plus sigma Y for security Y, and this is the optimum weight that is to be taken where the securities are perfectly negatively correlated. But from where this formula is generated, to know that we have to follow our past classes where we measure the weight that is to be assigned for security X and security Y, where the securities are perfectly negatively correlated. If you follow the past classes, then you will get the method by which this formula for determination of weight was generated. So by using this weight, we have to calculate the weight of security X and security Y, and since the weight is properly calculated here, the portfolio risk is become equal to 0, and this is also supported our theoretical knowledge. We know that where the securities are perfectly negatively correlated, then we have the portfolio risk is equal to 0, and this is supported by the answer also.